Hello, our most valued student. My name is Confident. Welcome to the review of the Mathematics N3 question paper that was written in April 2021. This is a national exam, and just to go quickly through this paper, what I thought was to early give you what was the Mathematics N3 paper all about. And it might have been that you already wrote this paper and you are coming across this video and you want to, in a way, get an idea how you performed. And it might be maybe already you're preparing for your final exams, you're writing in the next exam block, and you want to ensure that what is the current trend in the setting up of the question paper so that you can prepare accordingly. Whatever the reason it is that we are in this video, what I want to promise you is that you will benefit from going through this review, because it in a way gives you an overview of what this paper was all about, what you could have done if you're in that exam. And just before I go through that, I will encourage you to subscribe to our channel if you are new to our YouTube channel, so that you can be notified of new videos next time we post them. And you can also share the channel with your friends and your colleagues so that they can also benefit from this. Now, you guys, if you subscribe, you're actually giving us motivation to say these videos are more important to you and you're benefiting from them. You can also leave the comment below and we will respond to you. And also, I just want to say to our subscribers that we are launching also a new feature, which is a subscription feature whereby you can get the latest information, such as when we are giving a full memo, like this particular question paper. Already there is a full memo that I've done. Now, in order for us to maintain the channel, in order for us to be able to give you all these videos, you understand that it always comes with a cost. So for us to be able to give you all the latest information and latest videos, we have actually to get a little bit of funding, and we depend on you guys now funding the channel. Now, if you're benefiting from it, you can subscribe to our membership. As I said, it's a new feature, which is our membership or our premium membership channel. And when you join in this channel, there is no obligation. You can cancel it anytime you want to cancel, but it will allow you to see the latest videos, especially when it comes to the full memo of the latest paper that was written. For example, this question paper, which was written on the 8th of April, there is already a full memo that I've done. And if you want to access the whole memo, you can then join our membership channel so that you can have access to that. It is not expensive. You can just check the join button and you can have different options for you to join. And I will also add in some options whereby you can even ask me questions directly, or send me a question, or send me some maybe problems that you want me to solve for you, and I will solve those problems and post them back to you. So this is a way of trying to engage with our subscribers. Remember, you guys are important to us, but at the same time, we have to keep the channel running, and to keep it running, there is some costs that are involved. Now, let me go back to this, the reason why I'm here. As I said, this is the paper that was written in April 2021, on the 8th of April 2021. And X paper means it was written in the morning. So it's Mathematics N3 again. It's a national certificate. It's a 3-hour paper. Then it says non-programmable calculators may be used. So you definitely need a scientific calculator if you're going to be able to answer this paper. It says this question paper consists of 6 pages and a formula sheet. And as I said, this is just a quick review, but I do more of the actual solving of the whole paper. As I said, when you become a member of, when you subscribe to our membership, then you can access this. So it's a 3-hour paper out of 100 marks. you know the general part whereby you have to do the instructions and go through the instructions, but my interest is in the actual question itself. Let us look at a few things that the examiner here was focusing on. Quickly, let us look at question 1 here. Now, question 1 was made up of 3 questions, and the total of this section was 18 marks. And the first part, it involved factorization. It says as far as possible in prime factors. It was 4 marks there. And the main part, if you are confusing how to factorize this, there is in my lessons, in my online lessons that I provide. If you want to subscribe, you can go to our website. Information is provided at the end of the video where you can access our online videos whereby I factorize such problems. They are very simple to solve. In this case, usually I use what they usually call the K method, or you say let p minus 1 be equal to x, or k. In this case, they call it the K method. So where there is p minus 1, you'll have a k there. You'll have a k, so that it is 2k squared minus 7k minus 15. You solve it and then later bring back the k. It is actually easier to get those 4 marks. Then 1.2, there's 2 questions here. 1.2.1, just think of it, guys, this was 6 marks. And you can't afford to lose these 6 marks. Now, what do I usually do with question 1, 2, 3? I can show you how you can prove all your answers in the first 3 questions, and you will know that whether you are doing the right thing or not. You can find a way of proving all your answers, and as you are moving through the first 40 marks of this paper, you can actually prove whether you are doing the right thing or you are getting it wrong, and you can have the assurance that you have passed the paper. Remember, the pass mark is 40%. For example, in the first one here, I can show you how you can prove I provide the proof how you can check whether you are correct or wrong. Even in this 1.2.1, it's a fraction, and it's addition here that involves a few things. There isn't much complication here. I can see there is a difference of 2 squares. There they wanted to trick you with that b minus a. You needed to change it to a minus b by introducing the negative there and then solving fractions. And it's 6 marks. I think they were very, very giving in this case, because 6 marks of such a problem, it actually usually sometimes given 3 marks. So this was 6 marks. To me, it was a bargain for you guys and a good way of scoring good marks there. So yes, that was the addition. And the next one, again, 1.2.2, it's still an addition. It's a fraction, but this addition involves some exponents. So you need to understand here, whenever there is such an addition, there is usually factorization that is involved, and this factorization involves some exponents. So I'll show you how you could have approached this. It's 5 marks. So I mean, these are good 11 marks that you can score, and you can even prove if you are going in the right direction. So I show you how you can use the laws of exponents to simplify that part. And I think here the examiner was also giving to say that was 5 marks. 1.3 was the question that involved the remainder theorem. As you can see, the factor and the remainder theorem here. It says f is equal to 2mx cubed plus x squared minus x plus 2. Says divided by that. Says the remainder is 5. Then determine the value of m. And this is 3 marks. It's actually much simpler here to say. You must remember to say x minus 2 is equal to 0, and then x is equal to 2. So you're going to find f of 2 and equate it to the remainder, which is 5. So where there is x here, you put the 2, you put the 2, you put the 2. So that is how you solve it, and then after that you will have to solve for m. It was also not difficult. It's just a routine problem. So 18 marks was possible to get them without much stress. And question 2 involved, question 2 again involved some fractions. When I look at question 2 and also question 1.2, I think in a way there's a little bit of repetition there. Just look at this question 1.2, if I can just show you here. Question 1.2, this one, exponents, and question 2.1 again, exponents. The information that you use in these two, the approach was not different. So these 4 marks, if you got the first 5 marks, you will get the first 4 marks. And as I said, once you master how to approach them, it was a bargain for those who were strong in this section of exponents. And I can't believe this, even question, just look at this, guys, question 2.2 and 2.2.1. I mean, this is now solving for x, but the approach again, oh my goodness, the approach is similar to the one that was in 1.2.2, just that this one now is an equation. But what you did in 1.2.2 and what you did in 2.1 is the same thing that is required for you to do in 2.2.1, and again it's 4 marks. So if you say the 5 marks of that plus the 4 plus the 4, which is 9, and it's 13 marks. So you could have actually gotten 13 marks if you are strong in that section. So for the next exam, don't go into that exam without understanding how to approach this. And I actually show you how to do that. And 2.2 was on logs. So you're simplifying logarithms is 4 marks. So these ones are what was key there. Okay, this is same base, same base, same base. So it wasn't really difficult. You have to apply, since everything is the same base and there is that number, you have to take everything on one side and then apply the laws of logarithms, mainly when you're adding and subtracting. Remember, when you're adding, you multiply the logs. When you're subtracting, you divide the logs. So that is what you needed to do. And then after that, you convert that into an equation, into exponents. Remember, from logs, you can change to exponents and then you find x. Remember, I said you can prove all these as you are working through. Question 3 is actually one section that I usually like, is making subject of formula. So it's 3 marks. It was not complicated. You were making here, say the subject of the formula. So this is standard. You have to just take 32, remove the 5, divide by 9. And then the other one, make y the subject of the formula. And here y is an exponent. So when you're making an exponent the subject of the formula, you introduce ln here or you introduce log. So that is what I also show you there. And okay, that was the end of this page. And then you go to question 3.3. Question 3.3 here focused on what is this? It focused on a word problem. This is a word problem where you come with says Busal, South Africa is a leading manufacturer in supply of quality automotive industrial products. At Busal SA, 1 millwright technician and 5 apprentice artisans earn 35,520 per month. However, 3 millwright technicians and 9 apprentice artisans earn 72,000 per month. Says determine how much a technician earns and how much an artisan earns. 5 good marks. A standard simultaneous equations. You're going to find equation 1. Come up with equation 2 from this statement. You'll get your first equation. And from the next statement here, you get your second equations. You solve for you make either the technician, you say is x, the apprentice, the y, then you solve for x and y. And You get your answer. 5 marks, I think, was a good bargain for that. 3.4, solve for x by completing a square. A section that I always emphasize is important, and I do that part also in my online videos. If you join our online videos, and you'll be able to see how you can solve that, and that is completing a square. And question 4 is on analytical geometry or coordinate geometry, question number 4, and usually it involves the questions that they ask in this question is always standard. So they give you the information, and this is the diagram of that information, and here as I say, the equations here is always standard. They want you to know how to find the gradient, the coordinates of E, and here, and you can see that point E, those lines means two simple things. It means this is E is the midpoint of these two lines. That line is equal to that. So there is a midpoint formula, the gradient formula, the equation of the line formula, which is perpendicular, you see. So you need to know that m1 times m2 is equal to -1, and then the coordinates of B, here coordinates of B, these are intercepts. You know, B is x-intercept. You need to know what happens in the x-intercept. Remember, y is equal to 0. Here is the y-intercept. And what happens in the y-intercept? X is equal to 0. D is the point of intersection. You need to also understand intersection is the point where you solve simultaneous equation of point D and equation AB. So those things are always something that you need to be aware of. And then the size of the acute angle, this is also the angle is found using the formula at the formula page. The equation of the line passing through that, which is parallel, is another part. How do you find the parallel lines is another part. So these are the marks, also allocations for that. You can see the total of this section was 18 marks. The length of AD, you just apply the formula, is 3 marks for the length. So analytical questions like these that rely on the formulas, and once you master these, they are not a problem to solve. Now question 5, if I can just show you question 5 here. Question 5 says figure 2 below represent as graph. So this is graphs. On question 5 they give you the graphs, and also generally you need to understand what is A, the x-intercept, and what is C, the x-intercept, what is B is the turning point, and remember turning point dy over dx is equal to 0. Here in the A and C, remember f of x is equal to 0, so you are solving for x to get x is equal to, this is x1 and this is x2, so you are solving for that, and that point there is the y-intercept, and in this y-intercept here x is equal to 0. So those are things that you need to go through, and then you can check the questions here. It says the x coordinates f of x at point A and C. X coordinates, you are solving for x when y is 0. The coordinates of the turning point, as I said, dy over dx is equal to 0. Those are good 7 marks. Sketch the graph. Now you're sketching this graph, is just 2 marks. This is actually the graph of a circle. Here it's a circle, and you need to know whenever it's minus which part of the circle is needed. Sometimes you don't need that, you only want the bottom. Sometimes you don't need that, you only want the other side. So you need to know which side you need to plot that graph. But this is a circle, and then if it says if f of x is that first principles, you see, differentiating from first principles, which I teach extensively in my online classes, and it's 4 marks. It's very interesting part here, which it's easy to follow. And dy over dx also, I think they were a bit stingy in this exam because it's 3 marks. Usually it carries good marks like 5 and 6, But what is important, you needed to convert this square root into x to the power half there, and then you needed to multiply it inside and know how to expand that. Then it says leave your answer with positive exponents. Okay, so this was another 16 marks. So in a way, the question so far is I cannot say it was difficult, but it was mild. You can actually go through this question, and for now I haven't seen anything that was challenging, which I will say took students by surprise. It's just standard and common. Also, this is the 5 marks. And then question 6 says prove that this is this, and you have to prove this is trigonometry. Now this section is on trig. It's 5 marks, which is 5 good marks from what I'm thinking, and you needed to prove that. But now already by inspection I can tell that. By inspection, okay, this one I can't tell, but the top one I can tell the examiner to put a square root and some trigonometry. Usually inside it will have a square, so that the square root and the square will cancel each other, and you will have something that will remain in brackets, which will be linked with the bottom. And then, so this is the side that you're going to choose. You get your 5 marks. Now calculate the value of b that will satisfy this equation. Now you have cos and you have sine. It's not difficult on this one. The moment you see this, you must know that it will end up being 10b. Remember, 10 is sine b over cos b. So you need to come up with that to say, how do you convert this sine and cos to 10? 4 marks, which was good, 4 marks. And 6.3, this is a triangle. This is different sizes. So this is a triangle. It's a non-right angle triangle, and usually here you think of things like the sine rule when you're in this space, the cosine rule, and the area. They like such questions here. So here the question says I'm not saying the question here, but let me continue. Oh, it says determine the area, see, of this triangle. This is 6 marks. This was, just the area. Remember, there is a formula. The formula is given area is equal to half AB sin theta. So now you needed to find 2 sides when they say half AB. So let's say you have a triangle like this. That triangle is A, it's B, and it's C. So this B has a small b opposite the A, has a small a opposite the C, has a small c opposite. So when they say half AB, so they'll be saying half A, see I'm making it blue, and the B, and then sine theta or sine C. In this case, it must actually say sine C. So this particular C must be the angle formed by those 2 lines, A and B. So you need to actually, in the same sense, you're supposed to find, already I've got 2 sides, my half AB, which will be, in this case, if I take you, this one is 8.6, I already know it. This one is 7, but now I need to know this particular angle, which is angle K. Now to know angle K, either that's why you use the cosine or the sine rule, but I show you which one was best there. And after finding it, it will give you this angle, and then when you get this angle, then you can find half AP. So the 6 marks that they are giving here was mainly challenging because you had one angle. You cannot use this angle, because if you use that angle, then you are going to have half A, which will be this side, and you need this side. Now to use this side, to find this side might be a challenge, because it's actually fine. You can use maybe the cosine rule. Remember, A squared is equal to B squared plus C squared minus 4AC minus 4BC cos A. So if you say here, you convert it to be K squared is equal to in this case is L squared plus M squared minus 4, I I think it's 2. I need to check that formula, but you need to there is a formula. I think it's 2 minus 2, not 4. So minus 2 LM and then cos K. Again, you don't know cos K there. Anyway, it might become an issue now to find that side. So, but anyway, as I said, I have a way. I already there's a video on this, on how I solved this. So let me not go through it in this review. This is just a quick review so that you can have an idea what the paper was about. 6.4, draw the graph which is represented by the following trigonometric equations. They just brought a basic cos graph just with 0,5, and between 0 and 360, that was the graph, and this is 5 marks. This was just a bargain. Here I show you how you can use your calculator, nothing else but the calculator, how you can use this table method here, which is 3 table, to say 0,5 cos, then you say alpha x, you close that. How you can use this to come up with the graph where you start from. You can see, say start from where, and then use where you end the step, and then you come up with everything. I can show you how to use this to give you all your points, and you literally plot that without problems. Now, total of this question was out of 100 marks, and if you ask me, was this a good 100 marks? I think it was possible to get a distinction of this paper. I mean, if you're an underdog like me, I will celebrate, especially on my distinction, because it was possible, guys, to get the distinction here. And even if maths is a challenge, getting 70%, 60%, 50%, if you worked on my previous revision sessions that I've been doing, both on the YouTube channel as well as those private students that I work with, I think they did well in this paper. Well, we will wait results, but usually such papers, I know without a doubt that they did perform well, because when we prepare even for the tougher questions that can come through. So yeah, this was the mathematics N3. And lastly, there was the formula sheet. Don't forget the formula sheet at the end of your paper. It's always given. They give you some formulas. You can see formula 1 factors, formula 2 logs. I haven't seen much of the questions in nowadays that involves this part, but just always know that this can become some of the questions they might bring. And then you have the quadratic formula number 3, but I see some errors with this formula because there are 2 negatives there, so that was wrong. It's minus b, not minus minus. And all right, there is the logs. You see the formula for the logs, and then the parabola, you have that formula for the parabola there. And what else do you have? And let me check. You have the circle. All right, and here these are the formulas for the circle. You have the straight line. These are the formulas. I think there's also an error there on m1 times m2 is minus 1 there, but I don't know why this formula sheet had some errors like this. But anyway, you needed to know, even look at this differentiation. This was actually, I would say, unacceptable for a national paper to have such errors on the formulas, because students will use the wrong formulas to solve this, and how are you going to penalize them if you gave them the wrong formulas? So you see, it's f of x is minus minus, which is wrong. It's just single minus. I hope there was an erratum on this paper so that students were made aware to correct that. All right, guys, but anyway, this was the paper. That was the end of the paper here. For this one, it's calculus differentiation. That's the one that I was just talking about last. So all right, guys, this is the end of the paper. As I said, that was written in April 2021. Now, just to give again what I was saying to say, there is what I'm bringing, a new feature whereby you can have a full view of these videos. You'll be the first one to view the memorandum of this video, how I approached it. Of course, some will say, But how do we know that it's the answers as they are? Well, from practice, I've discovered that at least, even if there were errors in that memorandum I did, but 90% is always a guarantee. So I will encourage you to join the membership so that you can actually see how these are approached. Remember, these are videos, they're not just memos whereby you look at the memo and you might not even understand what it is about. So these are videos where I explain. Sometimes I give an alternative answer. So it is a good one for you to use as you prepare for your final exams. But you need to be part of the membership, and it's just a little contribution. I can't say you are being charged, but it's an appreciation in a way. As I said, bringing these videos does cost some money to maintain, and in as much as we want to, I think we have seen that the channel is extended from grade 8 to grade 12, from N1 to N4, both maths and science, and for us to do that, we need a team behind, and that team needs also to be paid. Now the site needs to be maintained, the website needs to be maintained, the videos need to be edited, and all these things require lots and massive amount of time, and just for you guys to get access to these. So just an appreciation is what we're saying. Just show a little bit of appreciation by joining the membership so that we can get the latest. And sometimes what I'll do with these memberships, I'll also give you a way of sending me questions that you feel like that section you're having challenges. I can even make a video for that section and upload it only for you members, and you can benefit exclusively for you members, because it is a sign that, or a way to say, I appreciate you joining the membership so that you can assist others to view some of these public videos that we're doing. So if you're doing that, you're not only doing it for the sake of the team that I'm having, but for the sake of others who are not able to access quality tuition at school or at college. And we are saying, let us help them and bring more of these videos. I hope, guys, this was benefit to you. This was just a review. There is a full memo, and after this section you'll see that I have a sneak peek. Sorry to say, it's not a complete video, but it's just a sneak peek of how already I was working on this question. So don't be angry that it is just going to show a little bit, maybe 1 or 2 questions, how I approach them, and then there'll be the end of that. But just to encourage you to join the membership so that you can also, as I said, assist in bringing this channel to more videos and everything. I hope this was of benefit to you. Just don't continue watching this channel as I'm bringing now a sneak peek, and watch how I approach this. Thank you. Let us start with question 1.1.1. Now, sometimes, by the way, students always ask, what are these signs? For example, I think you can see they've got these signs. I think these are more like of an official watermark for that question paper from the department. So what they do is they mark that paper to officialize it, to say for mathematics N3, this is the acceptable paper for that block. So it's got nothing to do with level of difficulty. Sometimes they put a strange face, like an alien face, and people will think, I think this paper was the most difficult paper, but it's just as a way of marking this paper to say it is the official paper. Now, as I said, let us look now at question number 1. And in question number 1, it says here, we need to says factorize as far as possible in prime factors. You see that? So we need to provide this. It says we need to give this in prime factors. So now if I can just have a little bit of cutting it out just to solve it in a new page. Now let us look at this. I just have to factorize this, and I say it says in prime factors. So what I have is 2 p minus 1 squared plus 7, and then I've got p minus 1 minus 15. So how do I approach this one? The first thing I'll do is, because to avoid confusion with this p minus 1, I will say let p minus 1 equal to x. So what it means is, wherever there is p minus 1, I will put x. Wherever there is p minus 1, I will put x. So how will it become? It will become 2. There is a bracket, but there is no need now to put the bracket. It will be x squared plus 7x minus 15. You see that? So that is what I have managed to reduce this to. And from there, I have now to use the product sum method. And I will encourage you to grab hold of my lessons on that one. I do a lot on the product and sum method. So you have to grab hold of my videos. And you can subscribe to our YouTube channel so that you can get more of these, or you can purchase some of the lessons. There is an online subscription that you can do. More information is provided at the end of this lesson. So using the product sum method, I'm looking for a number. When I multiply, I get minus 30. That is 2 times 15, which is negative 30. And when I add, I get 7x. So that number, I think it's 10. 10 and 3 will give me 30. So it will be 2x squared. I'll start with the positive 10x because 7 is positive, minus 3x. So 10 minus 3 is that 7, and then minus 15. When I've done that, look at the first two. 2x is common. When I factorize 2x into 2x squared, it is x plus 5. And then take out negative 3, and then I'll still have x plus 5. So the aim was to come with these two brackets. So when I write it, inside the bracket is thus x plus 5, and outside the bracket is 2x minus 3. Alright, so this is what I have. But remember, as we say but here, we said p minus 1 was equal to x. So now, where there is this x, I bring back the p minus 1. Where there is this x, I bring back the p minus 1. But in this second one, I must, because of that 2, I must protect it with a bracket. So what I will have is, I will have, where there is x, is p minus 1 plus 5. And then on the other one, I will have 2 into p minus 1, and then it's minus 3. See that? Then I'll have equal to, so don't leave your answer in terms of x or whatever you called it, because it will be wrong. Now p minus 1 plus 5 is p plus 4, and then I will have on the other one, open this bracket and open this bracket. It will be 2p minus 2 minus 3. So you'll have there p plus 4 and 2p minus 5. Then this becomes the final answer, and I think this was worth, if we can check here, it was worth how many marks was this question? It was worth 4 marks. So it is a good 4 marks that you could have taken advantage of. So if you look at it, it is how they are going to mark you there. The first thing that they were interested in is the factorizing. For example, they can actually, if you're going straight like that, they will give you 2 marks there. But and then after that, simplifying, they will give you a mark, and final, they'll give you a mark. But because you're working through like this, they will also give you, for example, a mark on this part. And then after that, for example, that and that can be 1 mark, half, and then this and this can be another mark, and then you get your mark there, and it's final. So this is how you would have solved this. But remember, in this question, it is very important to always test your answers. How do I go about that? When I'm testing my answer, what I do is I check on my value of p. For example, let me say let p be equal to 6. So what I'll do is I'll put 6 in the final answer here, where it says p plus 4 and 2p minus 5. So I'm going to have here to say in brackets, if p is 6, so I'll have 6 plus 4, right? And then I'll have 2p, 2 bracket 6 minus 5. So the answer that I'm going to get, I'm getting a 70. So now I'm going to input this into my original, which is at the top there, to see if ever with the value of p am I going to get the 70. So going to the original is 2 bracket, remember p is 6 minus 1 squared plus 7, and then it's 6 minus 1, and then it's minus 15. So if it gives me 70, it means the factorization from the top to the bottom has not changed. So you can see that I'm getting that particular 70. So the first thing is, I know my first answer is correct through this proof. So always try that. It will always work for you. So in every, especially question number 1, question number 2, even question number 3, you will see that I prove most of my answers like that. So let us move on to question 1.2, and this is 1.2.1. Says simplify, and this is what we're given. So in this one, if I can take also just to cut this out, it's 6 marks, guys, and you wouldn't want to miss those 6 marks. So if I can have that, if we were to simplify this, now just look at this. It says 2ab over a minus b squared, a squared minus b squared plus b minus a plus a over a plus b plus 1. Now, because of my experience, it will be easier to approach this, but let me show you what I'm thinking here. The first thing that I need to focus here is this a. See that one? Which is a squared minus b squared. Now I must remind myself that a squared minus b squared is a difference of 2 squares, which when I factorize it, it is a minus b, and it is a plus b. So that one is simple. Identify that this is a difference of 2 squares, and then the next part is to focus on that. Now you see, I have here a minus b, but it is saying at the bottom there it's b minus a. So the aim is to write this b minus a in terms of a minus b. So now how can you do that? You can take out a negative at the bottom here. So if you take out a negative, what you'll have minus b plus a. You take out a negative, you interchange the signs. So you can see that it's minus b plus a, but if you write it properly, it will be minus bracket, start with the a, it's a minus b. So you see that it has managed to match that. So actually these two denominators, in a way, they are the same. So that is the main thing that the examiner wanted to bring here, to say, are you able to identify the difference of 2 squares, and are you able to write this b minus a that you're given here in terms of introducing that negative, and you're saying a minus b. So that was the main thing that they wanted to bring there. So now if you are solving it straight away and you are able to recognize that, how are you going to solve it? You're going to say equal to, you've got 2ab over, then you write your a minus b, remember difference of 2 squares, and you've got your a plus b. They will understand that you understand that is a difference of 2 squares over a. Now you see, I have a positive sign, then I'll say over, then I'll write a, take out that negative, and then I'll write a minus b like this. Remember the part I told you to interchange, to take out the negative from b minus a, and then it will be plus a over a plus b plus, now 1 is just 1 over 1. You can just do that. And then when you have done that, what then you need to do is to identify your common denominator. Actually, you can actually recognize that this negative will come and affect that negative. So instead of a positive there, it will change to become a negative. For example, if I take a calculator and I say to you, in this case, just like any number, if I say, for example, I say 1 over minus 2, you'll see that the whole fraction is affected as minus 1 over 2. So you see that even if the negative is at the bottom, it will affect the whole fraction. So it means this negative here, just to avoid a lot of steps, I can come and remove that positive and make it into that negative. So let me make it actually a different color so that you remember what I mean. Remember that negative which was down, it went to affect that positive there to become negative. So now I'm able then to write the common denominator. You see I've got a minus b here, and I've got a plus b, right? And then I still have something, a minus b, which is also in my denominator, and a plus b. That is the main thing that they wanted to bring across there. And then this is all over. Now you can do your fraction to say a minus b, a plus b into a minus b, a plus b. It's 1 times the top, which is 2ab, minus, remember that negative sign, and then a minus b into a minus b, it will cancel to remain with a plus b, times the top, which is times a plus b, and then plus a plus b into a minus b, a plus b. The a plus b will cancel to and then times the top, which is a, and a minus b, and then you continue there to say plus 1 into a minus b, a plus b, times the top, which is 1 times a minus b and a plus b. So that's what you're having. If you then continue solving this, you need to expand or open up these brackets so that wherever there is a bracket, this multiplies and that multiplies, this multiplies and that multiplies. Alright, so if I have that, and remember when we open the bracket here, a minus b, a plus b was this part, a squared minus b squared. This is what you're having there. So you can actually write it as a squared minus b squared when you take it back. So what do? Let's open up the bracket. You are having here 1 times 2ab, which is 2ab, minus a squared, and then negative a times b is negative ab, and then a times a again is plus a squared, then again minus ab, I'm expanding guys, and then which is plus, remember this is a times a, which is a squared minus b squared. I'm taking it into the way it was at the beginning. Then you divide by a minus b and a plus b. Now if you move on and solve this, you have got 2ab. Now you can see that this minus a squared plus a squared will cancel, and then you can add minus ab, it will become minus 2ab, and then you've got plus a squared minus b squared, and you've got all over. You still have your brackets, a minus b and a plus b, and then you just continue with this scenario. What you have now, look at the 2ab minus 2ab, you see that? Then you have now, just have a look, you are having a squared minus b squared. But you can recognize that even the bottom is a minus b, a plus b, which is a squared minus b squared, such that you can now cancel all of it so that you can get a 1. You see that? Or you could have converted this into a minus b back and a plus b, because that is what it was before. Remember, if I take it into this part, see that? If you take it there, you'll have that a minus b, a plus b, such that this and that and this and that would have cancelled. So by the end of the day, your answer was going to be 1 here. Now again, you need to test it. For testing, let me just say, for testing purpose, remember we got a 1. You just choose any value of A and B. So let's say A is 2 and B is 5. Just choose any values that comes in your mind. Now with these values of A is equal to 2, B is equal to 5, I'm going to use these values and input them in the calculator to say fraction. I've got, remember A is 2, so it's 2 bracket 2, B is 5, so where there is B I substitute 5, and there is 2 squared, B is minus 5 squared, and then plus another fraction, A is 2 over, B is 5 minus A is 2, and then plus, and then I've got A is 2 over A plus B, which is 2 plus 5, and then plus 1. Remember, this must give me a 1 at the end of the day. So if I say equal to, you saw that I got a 1, and if I'm getting a 1, it means my simplifying then is correct. It doesn't matter whatever number you choose for A and B, it will simplify to 1. Then it means my simplification is correct. So you see that another one that I'm testing again, which was 6 marks, which means already you have got around 10 marks that you are able to test and know that at the end of the day you got it right. So that was that. It was a fraction scenario, and it's your 6 marks here. Let us go to 1.2.2. Now if I can just erase this part, from the look of it and the diagram drawn below, you can see that it is coordinate or analytical geometry there. It says figure 1 shows a straight line AB. So if I can try, yes, I think everything can fit. Figure 1 shows a straight line AB. You can see here I have my A, I have my B, with A on the y-axis. So there is A on the y-axis, and it says and B on the x-axis. AB is extended to C. See that C line? Line OD, there is OD, is perpendicular to AB. So which means here we have, the moment they tell us that, it's information we have, it's 90 degrees. And then N cuts AB at point D, which is 4, 6. We can see that point D there, 4, 6. E is the midpoint of OD, so E, there is that E is the midpoint of OD. Now there's a lot of information they've given, so they'll give us some questions. It says determine the following. So the first part is 4.1 is the gradient. Let me try to work some of this question here. So actually it's 2 marks. So what do they want? The gradient of OD. OD, the gradient of OD. You know that point O is 0, 0. Now you are not given the formula for the gradient in your question paper, but you remember the gradient. M for gradient is y2 minus y1 over x2 minus x1. That is the formula for gradient. So here you can say gradient, which is m of OD according to the to what you're given there, which is equal to, so you have to choose your y1 and your y2. So I'll have this as my x2 and my y2. This first one is my x1 and my y1. If I've gotten that, so my y2 there is minus 6, my y1 is negative 0 over x2 is 4 minus 0. So the gradient there, the calculator will be of handy to get that. So what I have, as I said, it's minus 6 there over, minus 6 minus 0 over 4 minus 0, and it will give me, in this case, negative 6 minus 0, which doesn't make any change, over 4 minus 0. It's simple, negative 3 over 2. See that? That's the gradient of OD. Then you can write gradient of OD is equal to negative 3 over 2. So that is how you can answer that question. The first question is 5. It says, question 5.1, figure 2 below represent a sketch of the graph defined by f of x is equal to 2x squared plus 8x minus 10. So this is what we are having on this graph. Alright, so let us look at the questions. 5.1.1 says the x-coordinate of the graph. Actually, what is it saying? The question was determine, number 1, the x-coordinate of the graph f of x at point A and C. So you see, they give you the graph and they are looking for this part and that part. Now, if you see this part is along the x-axis, so these are, in a way, these two, we call them the y-intercept. Actually, it's not the y-intercept, it's the x, because it's cutting the x-axis, so it's the x-intercept. So along the x-intercept, y is equal to 0, and our y in this case is our f of x, so f of x is equal to 0. So when you solve it, what I will have, I will be having 2x squared plus 8x minus 10 is equal to 0. Now I can divide everything by 2 there. You know, just to simplify it, it will be x squared plus 4x minus 5 is equal to 0. This one, you use product sum, you can solve it much quicker because it's more simplified. So you will have here, I think it's x plus 5 and x minus 1 equal to 0. So you get the first one, x plus 5 is equal to 0, or x minus 1 is equal to 0. Take positive 5 to the other side, you've got x is equal to minus 5, or x is equal to, this one jumps there to give you a 1. If you look even in the diagram, the minus 5 there is better and 1 is there is better. Says find the x coordinate there. So the x there is negative 5 and the x there is a 1. So that was this question 5.1. It gave you 3 marks, which it is good marks. I think for the question you're just solving for x there, and we've been solving for x by factorizing. Now this is more than once. So now let us move on to 5.1.2.